What is stoichiometry? Basically, stoichiometry is the branch of chemistry which deals with the calculations between reactants and products. For example, when hydrogen reacts with oxygen, it forms H2O. Very simple. Now it is a balanced chemical equation. Now, if I ask you if 8 gram of hydrogen reacts with excess of oxygen, how much water is formed? How much water is produced? It means from 8 gram of hydrogen, how much water can be produced? Now, this type of calculation is done in stoichiometry. There are 5 steps to calculate these calculations for these calculations. Okay, those are here. First step is write equation. Second step, balance this equation, whatever you have written here. Okay, balance this equation. In other words, we can write these 2 steps as a single step. Write balanced chemical equation. So you have to write correct balanced chemical equation. Number 1. Okay, now move to step number 3. Change gram to mole. Okay, let me write. Change gram to mole. Value will be given in grams. You have to change to moles. How can we change gram to mole? We have already discussed. Okay. Step number 4. Mole ratio method. Mole ratio method. This is new for you. Okay, we shall discuss what is this. Step number 5. Change mole to gram. So after step number 4, your answer will be in moles. So in step number 5, you will change these moles to gram. So sorry, if 8 grams of a hydrogen reacts with oxygen, excess of oxygen, how much water is produced? Okay. Now what is first step? Write equation. What is our equation? Equation is when hydrogen reacts with oxygen, it forms water. Now balance this equation. Let's balance this equation. 2 steps finished. First 2 steps will be given in your question. So change gram to mole. What is our question? Question is 8 gram of hydrogen. Now 8 grams of hydrogen. Let me change. Okay. So 8 grams of hydrogen is given. Now change gram to mole. How will you change? Gram of hydrogen down and mole of hydrogen up. Same like yesterday you have done in your exam. Change gram to mole. I told you when you change gram to mole or mole to gram, you have to calculate molar mass. So what is the molar mass of a hydrogen?
2.
1 for hydrogen times 2, it is 2. 2
18.
gram is equal to 1 mole. So 2 with gram and 1 with mole. Gram of hydrogen cancel. When you use calculator, it is 4 mole of hydrogen. Any question, boys? Just we have changed gram to mole. Any problem? Is it okay?
Yes,
Okay, good.
yes.
Now, this is your step number 3 finished. Step number 4, mole ratio method. Mole ratio method. What is this mole ratio method? Take your answer from this step number 3, 4 moles of hydrogen. Multiply and divide. Okay, friends, for mole ratio method, use this equation. Now, what is given in your question? What is given? Malum, hydrogen. And what is matlub? What you have to calculate? Water. Because it is written, boys, when you see our last slide here, it is written 8 gram of hydrogen reacts with oxygen. How much water? How much water? So water is matlub. Okay. Now, what is given? Hydrogen. How many moles of hydrogen? 2
4.
moles. 2 moles. This number is mole. So you will write given down 2 moles of hydrogen. And what you have to calculate? What is matlub? Water. How many moles here?
2.
2.
2 moles of water up. I told you is given, always write it down, and what you have to calculate, what is matlub, what is majhul, you have to calculate, you have to write up. Okay. Now mole of hydrogen cancel. 2 will be cancelled with this 2. What is your answer?
4 mole of H2O.
Excellent. 4 moles of H2O. Now your step number 4 finished. What is step number 5? Change mole to gram. How can you change? Take your answer. 4 mole of H2O, multiply, divide, mole of water down, and
Gram. Up.
grams of water up. Now when you change mole to gram or gram to mole, you will calculate molar mass. So what is the molar mass of water? It is equal to 1 mole. So 1 with mole and 18 with gram. Mole of H2O cancel. 18 fours are 72 gram of water. Yes, boys. Yes, this is answer. Good. Now you see, from 8 gram of hydrogen, we can prepare 72 grams of water. Okay, students. So this is the method. This is called stoichiometric calculations. Okay. Now, guys, listen. Step number 3, step number 5 is very simple and easy. Change gram to mole, change mole to gram. And step number 4, use this equation. Use this equation. And don't use this equation in step number 3 and step number 5. Be careful. Be careful. Okay. Many students wrote this too here. Here. It's wrong. It's wrong. You will use this equation whatever here. Okay. Whatever in the equation. You will write that in step number 4. And in step number 3 and step number 5, you will write 1 with mole. 1 with mole. Yes, boy. Now any question?
Will you give us after the break?
I will give you more than one example.
Okay.
Okay, so don't worry. Yes, it's very important. We will discuss inshallah in 2 or 3 more examples. Okay. Now, what is the question? Question is, if 856 gram of glucose is consumed by a person over a certain period, what is the mass of CO2 produced? So first of all, we should write equation. I will give you equation. Okay. Let's write it. C6H12O6 plus O2, it gives us CO2 plus H2O. Now balance this equation. 6 carbon dioxide, 6 water molecules, and 6 oxygen. So it is balanced chemical equation. Your first 2 steps finished. Now, what is step number 3? Change gram to mole. So step number 3, I am writing it here, change gram to mole. Okay, now 856 gram of glucose, it is given. So 856 gram of glucose multiply, divide. What will you write down? Change gram to mole. Gram of glucose down and mole of glucose up. Okay, now I told you when you change gram to mole or mole to gram, you have to calculate molar mass of this compound. So what is the molar mass of glucose?
180.
180.
Very good, 180 gram. Okay, so 180 gram is equal to 1 mole. So 1 with mole and 180 with gram. Gram of glucose cancel. Now 856 divided by 180, what is your answer? 4.75 mole of glucose. So your step number 3 finished. Okay, step number 4. What is step number 4? Mole ratio method. What is this mole ratio method, boys? I told you, take your answer here. 4.75 mole of glucose multiply, divide. Now, here is the problem, boys. For mole ratio method, I told you, you will use this equation. You will use this equation, this balanced chemical equation. Now, what is given? We are given glucose. How many moles here? 1. So
1.
you will write 1 mole of glucose down. Okay. And what you have to calculate? What is the mass of CO2? So CO2 is to be calculated. So how many moles of CO2?
6.
6.
Very good. So you will write 6 moles of CO2 here. Okay. Mole of glucose cancel. When you will use calculator, it is 6 5s are 0, 6 7s are 2, 5, 0.64, 24, 28. 28.5 mole of CO2. This is your answer after step number 4 in moles. Now, what is step number 5?
Change
Change.
mole
Mole to
to
gram.
gram.
Very good. Excellent. So, take your answer from step number 4. 28.5 mole of CO2 multiply, divide. What will you write down? Mole of CO2. And here gram of CO2. Now, when you change mole to gram or gram to mole, what will you do? You will calculate molar mass. So what is the molar mass of CO2?
180.
12 plus 32, it is 44. So 44 gram is equal to 1 mole. 1 with mole, 44 with gram. Mole of CO2 cancel. When you use calculator, 28.5 multiplied by 44. What is your answer? 1,200. How much, boys? I don't have
54.
calculator. Okay.
50,
1250.
1254.
54 gram of CO2. This is your answer. Yes, boys. Any question? No.
In step 4, why did you wrote mole of glucose in the down?
Where? In a step number?
Step number 4. Why did you write mole of glucose in down?
Here, because it is given. It is given here. What is given we have? We have glucose. So how many moles of glucose here? Okay, let me.
1 mole.
That's why. Boys, look. You will use in mole ratio method this equation. You will use this equation. Only this equation in mole ratio method. Okay. Now in mole ratio method, what will you do? What will you use from this equation? You will use number of moles of given, and you will use number of moles for that is you have to calculate, that is matloob. Now why are you not using this oxygen? Why are you not using this water? Because we don't need oxygen, we don't need water. We are given glucose, we have to calculate carbon dioxide. So what is the ratio? What is the ratio between given and to be calculated? That's why it is called mole ratio. Mole ratio. Okay. So ratio between given and to be calculated, between malum and matloob. Clear this one?
Yes, but
Okay.
I
Now,
have other question.
okay. I'm coming. So now question is, what will you write down and what will you write up? I told you what is given, always write it down, and what you have to calculate, always write it up. Yes. Now ask me question. Yes. Yes, boys. Any other student? Any other question? No question? Okay. Okay, students, now one thing more. Very important. We are using these 3 steps in 3 lines. Number 1 here. Okay, let me write it with blue. Here, first line, second line, third line. We can use all these 3 steps in one line. Very simple and easy. That is easier than this one. I will show you how. What is given? 856 gram of glucose. Multiply, divide. What will you write down? Gram of,
Gram of glucose.
and what will you write up?
Mole of glucose.
Mole of glucose. Good. Okay. Now multiply, divide. This is step number 4. Then multiply and divide. This is step number 5. Okay. Okay, friends. Now this is step number 3 finished. This is step number 4. Here you will use this equation here. What is given? Glucose. You will write moles of glucose. How many moles? 1. And what you have to calculate here? Carbon dioxide. So 6 mole
6 mole.
carbon dioxide. Now, in step number 5, you will write same. What is here? Mole of CO2. Write mole of CO2. And here gram of CO2. So here in step number 1 and step number 3 and step number 5, one with and with the gram molar mass. So what is the molar mass of glucose? 180. And what is the molar mass of carbon dioxide?
44.
44.
44.
When you use calculator, all this gram of glucose cancel, mole of glucose cancel, mole of CO2 cancel. We have only numbers. So when you use these numbers in calculation, you will get 1254 gram of CO2. Same answer. Okay. Okay. Now move to next. I will tell you how to do this one. And the second method is easier, in one line method. Okay. Here we have another example. all alkali metals react with water to produce hydrogen gas and the corresponding alkali metal hydroxide. A typical reaction is that between lithium and water. Good. How many grams of lithium are needed to produce 9.89 gram of hydrogen? Yes, boys. What is the question here? Oh my goodness. Okay. Here we have. What is given? Step number 1, write equation. Equation is already there. Step number 2, balance this equation. It is already balanced. What is step number 3? Change gram to mole. Okay, now
Change
we
gram.
use these step number 3, 4, and 5 in one line. Okay, how? What is given? 9.89 gram of hydrogen. So you will write 9.89 gram of hydrogen. Multiply, divide. Okay, step number 3. Step number 4, mole ratio method. Step number 5, change mole to gram. Okay, now what will you write down? Gram of hydrogen. What you have to calculate here? Mole of
Mole of hydrogen.
hydrogen. Okay, now here same thing here. Mole of hydrogen down. Why mole of hydrogen down? Because this is mole ratio method. What is given? Hydrogen. So mole of hydrogen down. How many moles of hydrogen here? 1 mole of hydrogen. And what you have to calculate? Lithium. How many moles?
2.
2 moles of lithium. This is step number 4. What is step number 5? Write same down.
gram.
Mole to
Mole of
gram
lithium.
and gram of
Gram of
lithium. Okay, friends, I told you write 1 with mole, 1 with mole in step number 3 and step number 5, and with gram molar mass. So what is the molar mass of hydrogen? 2. What is the molar mass of lithium? 7. So very simple. Use calculator. Mole of lithium cancel. Mole of hydrogen cancel. Gram of hydrogen cancel. 2 will be cancelled with 2. So just multiply 9.89 with 7. What is your answer?
69.23
Gram of lithium. This is your answer. Yes, boys. Any question? If you have any question, you can ask me, boys. Don't be shy, because if you will not understand this, you cannot understand the next topic. Yes.
maybe you can in the question maybe he will ask me how many moles and he give me grams.
Yes, I can. Yes, good. Very good question. Boys, look here. Here is very simple. Very good question. Sorry, let me do this one. If I ask you number of moles, no need for this step number 5. Just stop it here. Your answer will be in moles. Okay. So if I ask you, write your answer in moles. How many moles of lithium? Okay. So how will you calculate? Just stop it here. No need to write this gram. This step, no need, because this step is mole to gram. After step number 4, your answer will be in moles. If I give you gram, you will change to mole and then use mole ratio method. After mole ratio method, your answer will be in moles. No need. Okay. here is a limiting reagent. What is limiting reagent? It is the same as we have discussed here. So let me ask one question before this one. All students have their breakfast? Did you take your breakfast? Because the example is about eatables. Yes, boys. Everybody is okay?
We are
Yes.
okay.
Yes, yes.
Yes.
Mashallah, mashallah. Okay.
Yes.
Okay, students. Mashallah. You have eaten sandwich or burger. That is King's Burger or McDonald's? Okay. How many things in one burger?
Uh, Three.
Three. Very good. What are those?
Buns, vegetables, and patty.
Very good. Pieces of breads. Okay, this one and this one. And one
Yes.
is, we can say, piece of meat or chicken.
Meat, yeah.
Okay, good. Okay, students, now, if I ask you, if I have 10 bread pieces, how many burgers I can make?
5.
5. Very good. If I have 3 chicken pieces, how many burgers I can make?
3.
3.
Is it?
3, yeah.
Very good. Is it? If you have any question, you can ask me.
No, it's clear. It's clear.
Okay, very good. Okay, students, now, when bread reacts with or attach with chicken, it forms, we can say, burger. This is our equation. Now, when 10 pieces of bread are attached with 3 pieces of chicken, how many burgers you can make?
3.
3, yeah.
Think.
10.
3.
5.
Very
3, yeah.
good.
3
3
plus
burgers. Excellent. Excellent. Okay, students, now, but still you have 4 breads are left because with the 3 chicken pieces, we don't have more chicken. Is it?
Yes.
But still
Yes.
we have 4 breads. Now listen. That substance which is used up first, which is finished earlier, that is called limiting reagent. Limiting reagent or reactant. Now this chicken pieces, these are finished up earlier. Before we have still breads, but these chicken pieces are finished, so this chicken is called limiting reagent. Another second definition. Now here from 10 bread pieces we can make 5 burgers, but 3 chicken pieces we can make 3 burgers. Now that substance which limits the amount of the product, which gives the less amount of product, we have this product here 5, here 3. But these chicken pieces, these limits our product. This chicken limits our product, so it is limiting reagent. Limiting reagent. Now, how to perform these calculations in our chemistry? How to find this limiting reactant or reagent in our chemistry? Now, this one is clear. What is limiting reagent? Any substance that is used up first, that is called limiting reagent. Second definition, any substance which limits the amount of product, that is called limiting reagent. Okay, now here we have. We don't have. We have given ammonia reacts with carbon dioxide, it gives us urea and water. In one process, 637.2 grams of ammonia reacts with 1142 grams of carbon dioxide. You have to find a limiting reactant. How to find? You will change this question into 2 parts. How? First 637.2 gram of NH3 and in other 1142 grams of carbon dioxide. Now we have two questions. We have to use step number 3, step number 4, step number 5 for this question. We have to use a step number 3, step number 4, step number 5 with this question. Okay, how to use? Let's do it. We are given 637.2 gram of urea. Multiply. What will you write down? Step number 3. Gram of
Gram.
ammonia. Mole of ammonia. Okay. Multiply, divide, then multiply, divide. Okay, what you have to calculate? Urea. So, what you have to calculate, just write grams of urea. And here, mole of urea. Now, direct method, boys. What will you write down? Same thing here, that is mole of urea. And here, mole of ammonia here. Very simple and easy, boys. Now, you see, what you have to write it here? That is given. That is given. Okay, gram to mole. And here, what you have to calculate? Mole to gram. And here, mole ratio method. And how will you write mole ratio method? Same thing will be here and same thing will be here. It's very simple and easy. Okay, I told you step number 3 and step number 5, write one with mole. Okay, here it is. Okay, let me erase this one. And with the gram, what will you write? Molar mass 17 gram because this is ammonia. And here urea, what is the molar mass of urea? It's 60 gram. How? You can calculate. So nitrogen 14 plus hydrogen 1 multiplied by 2, it is 2 multiplied by this 2 plus carbon 12 plus oxygen 16. When you use calculator, it is 28 plus 12. It is 16 multiplied by 2, 32. 32 plus 12, 44 plus 16, 60 gram is equal to 1 mole. So 60 gram with molar mass and 1 with mole. Okay. Now what will you write here? Boys, look. Here you have ammonia that is given. How many moles of ammonia? 2. You will write 2 with ammonia. And how many moles of urea? 1. 1 with urea. So when you have finished, so cancel gram of ammonia, cancel. Mole of ammonia, cancel. Mole of urea, cancel. So when you use calculator, what is your answer? 637.2 multiplied by 60 divided by 34. What is your answer? Calculator 637.2 divided by 34 multiplied by 60. It is 1124 per gram of urea. Okay, friends, now this is your first step. Now in the second part, you will take 1142 grams of carbon dioxide. Multiply, divide. Again, listen, Abdurrahman, listen it carefully. This is your step number 3, step number 4, step number 5. Okay, what will you write it down here? Same here, gram of carbon dioxide. Because it is given. And here, write mole of carbon dioxide. So what you have to calculate? Urea. So you will write urea, grams of urea here. Now, here given grams of carbon dioxide because it is given, and here gram of urea to be calculated. Okay. Now here mole of carbon dioxide, just opposite gram to mole, and here mole to gram. So mole of urea down.
Why you wrote gram of urea?
Because you have to calculate. Urea is prepared here. Look, urea is prepared. So what you have to calculate, that is urea. Urea is majhul. Okay. In both cases, in limiting reactant, in both cases you have to calculate the same reactant. Okay, same product, whatever is given. Clear this one? So here you have calculated urea by using ammonia, this ammonia. Now you will calculate again urea by using this carbon dioxide. Okay. Now 1 with mole, step number 3, step number 5. And with grams, you will write molar mass. What is molar mass of carbon dioxide? 44. And with urea, it is 60. Now what will you write down? You will use this equation here. Now what is given? Carbon dioxide. How many moles of carbon dioxide here? Yes. Yes, young man.
1.
1 mole.
Very good. That is 1 mole here. So you will write 1 mole of carbon dioxide down. And what will you write up? How many moles of urea?
1 mole of urea.
1 mole of urea. Why here is a trick. What is written here? Write the same here. And what is written here? Write it here. And these values will be from your equation here. It is very simple and easy. So gram of carbon dioxide cancel, mole of carbon dioxide cancel, mole of urea cancelled. So 1142 multiplied by 60 divided by 44. What is your answer?
1557.
1557 gram of
0.27.
no problem. No problem. Okay, friends, now we have two answers. This answer and this answer. Now tell me which answer is the smallest answer? Which one is smaller?
From ammonia.
Very good. Now this answer is the smaller answer. Which gives you this answer? Ammonia. So ammonia gives us least product, smaller answer. Then ammonia is the ammonia is the
Limiting. Yeah.
limiting. Very good. Excellent. Yes, boys. Any question?
What about carbon dioxide?
Carbon dioxide is in excess. It is in excess.
That's
Yes, yes. So that will remain unreactive because we have finished ammonia. So if we have finished one thing, so what is the use of second? Nothing. That is useless. Okay. Okay. Okay, friends. So this is our today's discussion. How to find a limiting reactant. There is also second part of this question. We will do that part inshallah in our next lecture, and it will also give you review about our this topic. Yes.